just because they move to the cloud does not mean they're ready to gain some of those big benefits of DevOps enablement. Big benefit being, ability to be more innovative, respond to market and customer demands. The way you can do this is by releasing changes frequently and at low cost, and DevOps enablement allow you to do that. So automation is a part of this, but it's more than that. It's also cultural change. Okay, no one can hear me? A few issues with people not being able to hear, but I think we're okay now. So to continue, I think, DevOps enablement, like I said, it's around being able to release changes frequently and at low risk. Automation is a part of this, but it's more than that. It really involves a cultural change within your organization, and you can only do that once you've reached a certain level of maturity with the cloud. So again, I'm Lorraine Longhurst. I'm an Agile DevOps coach with Bulletproof, and Shiva.
Thanks, Lorraine. My name is Shiva Narayan-Swamy, and I'm a solution architect with AWS, working mainly with partners like Bulletproof. In my spare time, I have an area of depth, which is basically DevOps and CI/CD, so I talk to a lot of customers around that in ANZ. Over to you, Lorraine.
Okay. So I think we'll take another little pause for a moment because there's definitely some sound issues. It sounds like everyone can hear Shiva, but they can't hear myself.
Let's move on to the agenda. So today we're going to be covering, we're going to start out with the cloud and DevOps misconceptions. So, what is the market saying around cloud and DevOps? What are people saying? And, can we really gain some of those benefits? Secondly, we'll talk about what we see as the key benefits of DevOps. So really around reduced risk in getting features out to the market quickly. And then Shiva is going to really focus on that next section, which is really around how to gain those benefits of DevOps. And then lastly, we're going to have a demonstration by Michael Howe, and he's going to demonstrate how web services can be used to enable you to reduce the dependencies within an application and therefore, enable you to release more frequently and at low risk. All right, so let's start with the misconceptions. The barriers, there's a number of barriers to DevOps and Agile adoption. And what's interesting in this particular survey is it shows that, the ability to change an organizational culture is probably the biggest thing. So the resistance to that change, and that's a hard thing to overcome. And that's something that needs to be in place when it comes to DevOps if you really want to gain the benefits. So let's talk a little bit about what some of those misconceptions are. First thing, lifting and shifting equals huge cost savings. So this is something that is definitely a misconception. You're going to receive some savings when you move to the cloud. But when it comes to actually getting those huge cost savings that some organizations expect, there's a number of things that you have to do to be able to take advantage of that. So we worked with a retailer a while ago where they just wanted to put some disaster recovery in place because if their website went down, it meant that there was a huge revenue loss. So they came to us and said, let's just move a copy of our website into AWS. The execs just thought it was a simple lift and shift. But when we looked at that application, we realized it was a legacy system, really had a legacy system architecture, and there were a number of back-end systems that we needed to integrate with. So rather than it just being a simple lift and shift, it really required a lot of application re-architecture. And the only way that was possible was by having the development team and the operation teams really working together. And that required a certain level of maturity when it came to DevOps. So in this particular case, we ended up just doing something simple. We said, okay, let's just put some of the product catalog up first. You'll get some cost savings, but you're not going to get those huge cost savings where you can have your customers actually buying online until you really have embedded that DevOps culture and have been able to re-architect for the cloud. Another misconception, it's operations responsibility to keep things running. So it's not good enough for developers to build something on their local machines and then just kind of throw it over to the testers and to the operations to deploy. It really needs to be that shared responsibility from the entire team that what is being developed is actually going to work in production. And the cloud makes that easy. It does make it so that it's easy to have an environment that you're developing in that looks the same as, or setup is the same as production, whether it's infrastructure and software. But you do need to make sure that that it is a shared responsibility. And one way to do that is definitely by something that we're doing at one of our customers. Actually, we're doing this at a number of our customers, where we give the responsibility of system and application monitoring to the developers. So we work with them and we say, maybe the new relic alerts that are coming in, those should go to the developers first. And if the developers can't sort it out, they should be working with the operations team, and together they should be resolving it. And that really, by giving them that responsibility, it really reduces the risk when it comes to issues in production. Okay, and the third misconception, containers will make our product releases risk-free. So yeah, that's a good one. Containers are definitely a hot topic right now, and they do definitely help. They definitely reduce the risk of releases, there's no question, because what it means is your environments are going to be consistent, right? So there's the self-contained environment with all the dependencies packaged in. But that's not enough. That's not going to make your releases risk-free. You need to have your entire delivery pipeline automated. So it's not just about your environments being the same, but it's also having your quality gates in place and having those automated so that you're ensuring that you are not introducing issues into your production environment. Okay, so next we're going to go into the benefits of DevOps. So DevOps, I think everyone knows this, it's all about overcoming the silos, right? So you've got this development team who wants change. They're listening to the business and they're saying, we need to be able to release features out to the market quickly, and we want to do that really frequently. Whereas the operations team is saying, well, we want stability. We want to make sure that we're not introducing issues into production that are going to bring the site down. And it causes a silo between the two teams. So a huge benefit of DevOps is overcoming that silo. I'm going to pass it over to Shiva, who's going to talk a bit more about the benefits.
Thanks, Lorraine. So what I wanted to share here was some experience from Amazon's own learnings and some of our customers as well. Lorraine, in the previous slide, talked about the wall of confusion and the separation between the aim that the developers have to change things fast and introduce new features and bug fixes faster. But we all know that invariably production issues are caused by some change. So the operation team wants to keep the production environment reliably up and running for their customers, so they are kind of hesitant to make the change. So we've created these two silos, and we've created two different teams and given them two different aims towards the same customer outcome. Within Amazon, I think in the late 90s, we realized this problem, and one of the things that worked for us was changing our team structure. So if you see Adrian Cockcroft, who is now one of the VP marketing in AWS, but at that time he was the chief cloud architect in Netflix, and I love a quote of his where he said, DevOps is a reorg. So he talked about how Netflix also changed their team structures so that everybody in the team is working towards the same customer outcome, which is customer satisfaction. So in Amazon, we call them the 2 pizza teams. These are team sizes, which probably about 2 pizzas can feed, presumably big New Yorker pizzas. So average team size is around 13 or 14 people in a team, all of whom are given a responsibility. So if I to take, for example, the Amazon.com page, and there's a shopping cart on the Amazon.com page, the shopping cart might be the responsibility of a team of 13 or 14 people. So they are responsible for the shopping cart, how it looks, how it performs, reliability and uptime and SLAs and everything around that. And they have API pacts with the rest of the systems or microservices that they interface with. Now, these 2 pizza product teams are encouraged to fail fast. They have full freedom to innovate. They have freedom to choose what language they want to write this on, what tools they want to use, etc., etc. By giving them that freedom, they are able to innovate fast, but also they have the accountability for it. So they control the feature roadmap for a particular service, in this case, a shopping cart. They're also responsible for running it in production. And as Lorraine mentioned, if there is a production issue or if there is a New Relic alert in the middle of the night because a change has gone in, who is best placed to figure out a way to fix it? It is the developers who actually made the change. So this two pizza team builds stuff and they run it as well. It also kind of promotes honest and open sharing. So there is never any finger pointing as to what caused the problem or who caused the problem. It is one big happy team. It also builds trust across organizational boundaries. I have a lot of customers who ask me, like, how can a two pizza team, which is like 13 or 14 people, have all the required skill sets? They need ops people, they need testers, they need developers, they need data scientists and security experts. How can one small team have all the skill sets? With Amazon, the way it works is the two pizza team is the core team which is responsible for that service. But we have several specialist teams around them who enable these two pizza teams to self-service. For example, we would have a team called the Builder Tools team. The Builder Tool team is responsible for all tooling around CI and CD and configuration management and everything like that. So they enable this two pizza team, which is actually responsible for the service, to self-service and use these CI/CD tools and help them innovate fast on their product. And again, this is a constant experiment, so you never have a perfect team structure. So we are always looking at what works and what doesn't work through what happens, what our customers tell us, and also through internal surveys, and we are always thinking of it as a work in progress. Over to you, Lorraine.
All right, so let's just summarize some of the benefits of DevOps that we're talking about here. So it's all about staying ahead of the competition by adapting requirements and releasing frequently and at low risk. It's about reducing the dependence on IT operations. So if there's just one person or if there's a bottleneck to do those releases, automation will help overcome that. And then thirdly, providing more cloud knowledge in-house within the development teams. Okay, so this is just a quote from the State of DevOps report from Puppet Labs. High-performing organizations spend 22% less time on unplanned work and rework. They are able to spend 29% more time on new work, such as new features or code. So what this is saying is, we all know that DevOps enablement will enable teams to be a lot more efficient, right? So they're going to be spending less time on production issues. But what I like about this quote is the second bit of it. So really that is enabling you to be more innovative, and that's a really big benefit there. And how is Agile tied to DevOps? Let me just give you a brief explanation of why I think they're so important that the two go hand in hand. So like I said, DevOps is about being able to release frequently and at low risk. And Agile is about being innovative, right? So being able to respond to changes in the market and being able to, again, release frequently. In the old kind of waterfall approach, which is what you see on the left, delivery doesn't happen until the end of the project. So whether it's 6 months, a year in, and it's at that point where development and operations start really kind of working together because that's when the issues arise. With Agile, you have to release out into production or have working software in a production-like environment every sprint. So that's what Scrum prescribes. Every couple of weeks, you want to get that minimum viable product out, and every couple of weeks, you want to be able to release production-ready software. The only way you can do that is by having a DevOps-enabled organization, right? So I've worked with organizations where their development teams, they're able to deliver working software every sprint, but when it comes to actually releasing out to production, they have major issues. So we'll go into a bit more detail on that. Over to you, Shiva.
Thanks again, Lorraine. In several conversations with customers that I've had who've asked me, why should I do DevOps or why should I move to the cloud? And what is disruption and why do I need to do continuous innovation? I've managed to distill all the long conversation that I've had into one sentence which really makes sense to me, which was, you want to do this because we want to deliver better features to our customers quickly, securely, more reliably, and cheaper. this is the reason I feel that we need to adopt DevOps practices and why we need to move to the cloud. And as I said, to deliver better features to the customer. So anything that we do, anything that a business does, it has to be customer first. The customer is in the middle of it, and if you are ever thinking of should I do this or not, work backwards and look at what benefit your customer is going to have. You might even be an internal team who don't have external customers, but you're still going to have internal customers. So always try to work backwards. So in this, I call this the continuous innovation loop. So the business has a business idea or a new feature idea. Presumably it is based on customer feedback or because of a gap in the market that you want to fill. You want to implement that business idea as soon as possible. And in Amazon, the way we do it is we basically create MVPs. We don't wait, a year or a couple of years or a few months to create that finished product. What we do is we create a minimum viable product and get it out there as soon as possible. So we want to be able to implement really fast. We want to be able to test it and actually release it. When we say release it, we don't want to cut any corners. Because we want to release often. We want to make sure that the release is secure, it is reliable, and it is cheap. Cost optimization is quite key as well from day zero. We want to release it and get customer feedback. And there are a few techniques where we can get customer feedback. So for example, if you're deploying on AWS, you can start doing utilizing techniques like blue-green deployments or build feature flags into your application so that you turn on a feature that you've just released to select set of customers so that you can get customer feedback. And now that customer feedback feeds back into your business idea. Maybe you want to pivot and change your idea a little bit and change certain things based on feedback. Now, the faster you are able to close this continuous innovation loop, the more features and the more customers you're going to keep happy and ahead of the competition you're going to stay. When you come onto AWS, the implementation loop becomes really easy, right? The idea from the business idea to get into implementation. You have several additional features that you can use on AWS which make it really easy. For example, we presumably want a database to implement a feature or develop a new application. Instead of installing a completely new database on a VM or an EC2 instance and managing it yourself, you have the option of choosing RDS, and you have multiple relational database service engines like MySQL and whatnot. You have DynamoDB, which is a NoSQL. So you have all these Lego blocks that are pre-made for you that you can use, which allow you to go from a business idea into implementation really, really fast, which allow you to close this continuous innovation loop quite fast. Can we go on to the next slide, please, Lorraine? Thank you. Again, I love this diagram because it talks about why we need to release fast. Lorraine mentioned that with Scrum, every sprint you want to produce production-ready code. The production-ready code actually has to be released as well, right? I see a lot of customers who adopt Agile practices and they do Scrum and they do sprints, but rarely do I see customers who are actually releasing into production at the end of their sprints, and it's quite important to do that. The reason is typical SDLC, we gather requirements, we do development and unit testing, we do QA, and then we actually do the release. That's your typical SDLC. When you do requirements gathering, that is basic. Theoretically, you're gathering the requirements, so there is some learning there, but you still don't know what you don't know. When you do development and unit tests and things like that, and test and QA as well, you are testing for known conditions. There are some customers like Netflix who are now starting to do, who have been doing for quite some time, chaos testing, which is basically testing for unknown conditions. So they introduce chaos into their system and see how their system behaves. There is a minimal learning there as well. But when you actually release it out into the wild, when you release it into the production system, and you have your customers actually using it, and you see how your system reacts, that is where there is a lot of learning. So we want to release as often as possible. I want to give you some statistics around what I mean when we say we want to release as often as possible. For example, Amazon.com in 2015 did 50 million deployments in the year, which equates to more than a deployment every second. That is how often we release. We have local customers in ANZ. For example, at the last AWS Sydney Summit, realestate.com.au talked about their release process, and they shared some very interesting statistics. So they shared the fact that they release into production every 3 or 4 commits. So every 3 or 4 commits that the developers in a team makes, that product gets bundled, tested, and released into production. So that is how often they release, and they gain benefits out of that as well. So the summary of the slide is release as often as possible. An interesting metric to measure how long you take to release is how long does it take for your organization to change a line of code. Say, for example, you introduce a comment statement in a piece of code. That should ideally not cause any production issue. But if you can gather metrics around how long it takes for that line of code to go into production, that will give you an idea of what your release cycle, you can currently get to. And then there are clever engineering practices that you can do to meet whatever fits your business needs. So when I talk about 50 million deployments from Amazon.com, that is a business requirement, or that does something for our business, that adds some value to our customers, which is why we arrived upon that number. You have to figure out what works for your business and do enough engineering to get to that level. Could we go on to the next slide, please, Lorraine? I wanted to correlate Agile and DevOps practices and see where they sit. So again, you have the business who is coming up with business ideas. So they write business cases, requirements, use cases, features, and plan, and they have go-to-market plans and things like that. The business talks with the developers or the implementation team who have to actually implement that business idea. This is where your Agile practices come in, where you're doing iterative developments and scrums and sprints and stories and things like that. So that gives you business agility. So business agility is where business is able to come up with new business ideas, and your organization is able to implement those business ideas as fast as possible. Now, those implemented business ideas have to actually reach the hands of your customers, and your customers have to use them and give you feedback. That is when you close the continuous innovation loop. Business agility alone is not going to give you that. To still get your implemented idea into the hands of your customers, you need IT agility. And that is where DevOps practices come in. DevOps practices like continuous integration and continuous deployment help with really reliable, secure, fast, small releases. And then you have IT automation, where, for example, in AWS language, you can pretty much create an entire SAP workload or any really complicated enterprise workload from ground up, completely automated, using things like CloudFormation templates or OpsWorks, or even configuration management tools like Puppet and Chef and things like that. So you can stand up an entire environment in a matter of minutes, deploy your application to it, test it, store your test results, and then delete your entire infrastructure. So that is real IT agility, which is possible on the cloud. Could we over to you, Lorraine?
We're going to go into, we've talked a lot about the benefits of DevOps. Let's talk a little bit about more around the specifics on how to gain those benefits and how we, how we can kind of gain some of the benefits that we talked about around, innovation and being able to release frequently and at low risk. So a big thing is collaboration. This is, across the entire software development lifecycle, you need to be collaborating. And this is where a lot of organizations are going wrong. I was talking to a fellow Agile coach the other day who was working for a big bank, and what he was doing was, he'd introduced Agile into the development team. So the first 3 steps of the software development lifecycle, they were doing things like, following the right software development practices, extreme programming. They were, when it came to actually releasing it, though, at the end of the sprint, they were getting blocked. And it's because there was a lot of governance in place, and there always is a lot of governance in place when it comes to banking. So in that case, although the developers were feeling like they were really agile, they were doing things like, ensuring that the definition of done was complete. They were doing pair programming, code reviews. They even had automated regression testing using Selenium and Jenkins. But when it came to actually releasing out to a production environment, they weren't able to do it. So there's a lot more to it, and that's where the collaboration side comes in. So that means what I'm saying here is that all the way through the entire software development lifecycle, the teams need to be collaborating. So developers, testers, operations, everyone needs to have shared responsibility so that you're finding issues early. So when developers check in their code, actually I'll go into this in a little bit more detail in the next slide as well. But also just to tell another quick story, Ubank, I don't know if you guys are familiar with them, they're an online bank owned by NAB. They came to us a number of months ago because they were struggling to stay ahead of the competition. So they wanted to be able to release more frequently. And again, we introduced Agile in there. They were able to deliver every couple weeks. But until they could automate the rest of the software development lifecycle and really collaborate with operations, they weren't able to move forward. So I'll go into a bit more detail about that in a sec. Okay, so how do you actually automate the delivery pipeline? Organizations, they may think that they are DevOps enabled because they're using continuous integration to automate some tests, and they move their code through from dev to test to stage to prod. But unless that deployment to production is actually low risk, you're not gaining the benefits you should from that automation. So to automate the delivery pipeline, you really need to find those issues early. So they could be issues with the software, so software defects. They could be scalability issues, performance, security. But the whole thing about automating the delivery pipeline is uncovering those issues as early as possible. So through the use of version control, using, whether you're using something like Git or GitHub, you want to make sure you're following the right development practices when it comes to branching and merging. You want to make sure there's no dependencies between the code. And when you check your code in, when your developers are checking the code in, you want to make sure you're getting immediate feedback. When it comes to continuous integration, so think when you're using tools like Jenkins, Bamboo, you want to ensure that your unit tests are automated, but also your regression tests, and that it's the right level of regression tests for your organization. You want to introduce additional quality gates that you can automate, and it really will depend on the level of risk that your organization is willing to accept. So that's where we talk about things like performance tests, security tests, anything that is required for your operations team to feel comfortable that what is being pushed through to your production environment is going to be low-risk deployment. So it's not just about consistency. So a big part of it is consistency between the environments. And like I said, the cloud makes that easy. But it's also about automating those quality gates and ensuring that the software you're developing has been developed for the infrastructure in production, so been developed for the cloud. I'm going to pass it over to Shiva. He's going to talk a little bit more about automation using AWS.
Sure, thanks, Lorraine. So again, this picture, I wanted to kind of drill down into how the dev teams and ops team can collaborate and the various life cycles in the whole SDLC until your code gets into production. So typically developers are used to this workflow. So you write application code, you write unit test cases, you build and compile and unit test and package your applications, and then you deploy your application, or your application is available for deployment. Developers are used to version control and artifact repositories like Artifactory and Nexus and things like that. Typically, IT ops have, in a traditional sense, haven't been writing code, too much code at least. I've not seen any bash scripts in a Git repository in the near past. So this is a new territory for them, but not something that is vastly different. For example, in an application lifecycle, when the developers are writing code, you already know there is an architecture towards which they're writing that code. So you know where that code is going to be deployed to. So is there, for example, let's just take a simple 3-tier web architecture. So there's a web server, there's an app server, and the database. So if you're writing code, say you're writing Java, you know that it is going to be deployed into an app server. In the AWS world, you already know that it is going to be auto-scaling set of Tomcat cluster, auto-scaling Tomcat cluster, for example. So you know the architecture. At the same time as the devs are writing code, your IT ops is starting to write infrastructure code in the form of CloudFormation templates or Puppet or Chef recipes, or a combination of all of these. You're starting to write your infrastructure code. When the developers are building and compiling, the equivalent of that in the operation sense is that you are creating your standard operating environments, you're bundling your AMIs, you're building your AMIs, or you're building your containers if that is where you're going to deploy to. And then once you build your AMIs or containers, the equivalent of say unit testing your application code in the IT ops world is you validate those templates. So you can say, for example, we've got enterprise customers who have strict, in the financial industry, we've got strict regulatory authorities validating the applications that they deploy to AWS, have very strict control. So for example, they validate their CloudFormation template. So if a CloudFormation template gets checked into your source code repository, there is a CI system which takes the CloudFormation template and validates it against those their enterprise rules. For example, they might be creating a highly secure, completely internal facing application, which does not need a route out into the internet, which does not need an internet gateway in the AWS VPC. So if somebody checks in a CloudFormation template, they are automatically testing the template for any route out to internet or any suspicious ports that are being opened in your security groups and things like that. If they find any of that, they automatically fail that build and they fail that CloudFormation template and immediately raise a notification. So that is what I mean by validation template. You can go further on and say that if I'm building an AMI, you can automatically do a vulnerability test against that AMI machine, Amazon machine image, using services like Amazon Inspector. If there is a vulnerability that you have found, or there is an unpatched version of a software that you're running, you automatically fail that build. And then again, you can automate deployment. So you can use things like AWS Code Pipeline, which can deploy CloudFormation templates, or other CI tools like Jenkins or Bamboo, which can also deploy CloudFormation templates and hence infrastructure on AWS. So you can automate the entire deployment. And when you get to the deployment part, you have ready-made infrastructure that is ready to be deployed in the form of CloudFormation templates and AMIs and combinations. Your application is ready to be deployed in the form of a WAR file or an exe file or an RPM or any binary. And then you have a deployment system which is basically deploying into your dev, test, DR and prod environment. And your deployment system knows what are the different characteristics required for these different environments. If you look at it, you're exactly going to be deploying the same application binary and hopefully the same production-like environment in your DR environment and your test environment. The only thing that changes is the config. So for example, in your test environment, you might want to switch on debug flag. You will be pointing to the test database. In the production environment, you would be switching off debug flag and pointing to the production database. So these are minor configuration changes which you can control using config files. The config files are basically your knobs and buttons to tune your application to be suitable to your different environments. And when we see this, the entire model, everything is in version control. So now your infrastructure is code. Because infrastructure is code, you can test your infrastructure like code. You can write unit test cases for it. And because your infrastructure is code, it is in version control. So you can version control your infrastructure and roll back if required as well. So those are some ways in which we see customers doing automation on AWS. Over to you, Lorraine.
Okay, so next we're going to go into a demonstration. Michael Howe is going to be demonstrating how we use web services to reduce deployment risk. So it's an example where we're going to be showing a team, two teams actually, that are developing a website. And they may be working at different paces. So you might have one team that wants to release daily and another team that wants to release, say, once a sprint. And as soon as you start doing that, you're introducing risk if you have kind of a monolithic application. So what Michael will be demonstrating is how we have used independent web services to allow for that. So you have a dedicated pipeline in Jenkins for each of those web services. So I'm going to pass it over to Michael.
Thanks, Lorraine. I'm going to run a demo which showcases how to achieve frequent and low-risk deployments with microservices. think of yourself as a startup. The development team started building a monolithic application. It started with 1 or 2 developers. People was happy because collaborating with 1 or 2 developers is fairly easy. Further down the track, the web application attracted more active users, which means more features are required to be released. The development team starts growing too, from 1 or 2 engineers all the way to 5, 6, even 7 developers. That means more features to be released each deployment, and the regression testing suite starts snowballing. The development team starts to get unhappy because their features get through the pipeline a lot slower, and the regression testing takes a lot longer to execute. Then we start introducing redesigning your web application with microservices. In the middle was the old monolithic application. On the blog side, it has a competition form and a login form. So we took those 2 things out as a standalone web services. So you have 1 engineer working on the competition form and 1 engineer working on the login form. A little background on the competition form is the competition form service, which holds the cosmetic stuff, while at the back actually calls a third-party form editing service, which allow the content management team to serve their competition form through to the main website. Let's have a quick look at how this site looks like. Here we go. Here is a blog. On the left is a competition form, and on the right is the login form. So in the demo, I'm going to showcase a scenario which the third-party form service is unavailable. Therefore, the whole competition form will be unavailable to the end users. Come here and comment this bit. What it does is it will simulate a downtime. Okay, now the code has committed to GitHub. What will happen is on Jenkins, you can see there's 2 separate pipelines, 1 for each service. This one has just been kicked off for the simulation for the service downtime has already been pushed through. So you could see, yep, in this pipeline, this is a dummy pipeline, which normally what you would do is you will compile your code, run your unit test, acceptance level testing, in this case let's say cross-browser testing for different browsers, and you push it into your dev environment, and then you would subsequently push into stage and all the way to production. But this is a dummy pipeline, but normally you would have manual interactions here and here, so which would be the testers involved in here to tell the code is ready to push onto stage for UAT, and then someone to make this final call whether this feature is ready to go to production. So now if we refresh this site here, this blog, okay, you can see the form application, the form service went down, but the rest of the site, the actual blog and the login form still work as it is. I have just demonstrated the scenario that a third-party service is unavailable, which brings down a service from the blog. But the blog itself and the login service still work as it is, which demonstrate a key strength of using microservices architecture, which is the services are maintained fairly independent. So those two services does not interfere with each other. Also means when you release new features in login, you do not need to run regression testing for your form application. It will be the same story around if you are releasing a new update for your competition form. It does not need to wait for the login service team to schedule their deployment, which consequently you will have more frequent releases. In the meantime, since those two services are completely segregated, you maintain two different regression testing suites, which also means low-risk deployments and smaller regression testing suite.
Thanks, Michael. All right, just to wrap it up, we're going to talk a little bit about the services that Bulletproof provides and then move on as a summary. Okay, so first of all, what we do at Bulletproof is we do help organizations on your DevOps enablement journey. So we can help you assess your current maturity, figure out what you need to focus on, what are the recommendations you should be taking to move forward. And we have a lot of expertise in AWS and the cloud, so we can help set up the pipelines for you. So just in terms of this diagram here, what you see is consult. That's where we would come in and we'd say, okay, let's do a DevOps maturity assessment. Let's assess things like, what are your development practices? How strong is the collaboration between your development and operations? Are you doing infrastructure automation? Where are you when it comes to automated testing, and how are you using continuous integration? We then, so it's a full assessment, and we would then say, okay, these are the recommendations on how you should move forward. And a lot of time, that's where we get into the delivery. A lot of the time, the recommendations involve setting up delivery pipelines. And it is about an enablement, so we do want to coach your teams so that they can do it themselves. We would set up possibly different levels of quality gates depending on the product that you're actually going to be releasing out. So some products you might want to be a lot more innovative. You need to release them, say, every day or every week, whereas others, it might be less frequent, and there's different kind of levels of automation required in those two situations. And then finally, support. Like I said, we do enable your teams. It's all about coaching, but if you need help, we're there as well. So we would provide proactive support if you want changes to those delivery pipelines that have been set up, but we can recommend things going forward if you want further automation tests and that kind of thing. So just in summary, we've got this happy looking team here where the developers have the change that they want and operations have the stability that they want. And I mean, just back to what I said at the beginning, not every organization who has moved to the cloud is really ready for that DevOps enablement, but you can still gain some of those benefits that we talked about incrementally as you go. So if you really want to gain what I think of as, or what we think of as the biggest benefit of DevOps enablement, that is being able to be more innovative, stay ahead of the competition by releasing changes to your software or your applications frequently and at low risk. You need to have those DevOps cultural changes in place as well. So that's automation, but it's also ensuring that your software is being designed for the cloud, and the teams are working closely together to have that shared responsibility that what is being delivered is actually going to work in production. So as a final next step, feel free to discuss us, to call us if you want to discuss your challenges. We've got this self-assessment tool online, so feel free. We'll be sending this link out. Feel free to print this out and fill it out. It will help you identify what areas you might need to work on, and then we're happy to help you in those areas if you're interested. So I'm going to pass it over to Phil, who's going to talk a little bit more about questions and how you can ask.
All right, thank you, Lorraine. And ladies and gentlemen, if you do have any questions, please go ahead. Use the Q&A panel found now on the left-hand side of your screen. Just type your question in there and be sure to hit the submit little bubble. Also, if you'd like to download today's presentation, you can do so from the resources pod there found on the center right And in the meantime, we will start to answer some of the questions that you do have submitted. And also, while the Q&A is going along, if you wouldn't mind filling out these quick polling questions just to get some feedback on your experience today. So with that, Lorraine, I'll turn the floor over to you to moderate any questions that have come in.
I think so. All right, so we've got one here. It's a question about the demonstration. So you talked about the move to microservices. How would the automated regression testing suite change based on this? Okay, so I guess that's a question for me. So when it comes to breaking down a monolithic application into microservices, you will need to break down that original test suite, because you would originally, if you just have a monolithic application, you would have one kind of giant regression testing suite for all your automation. What we would recommend is that you do have one test suite for each microservice, and you would focus just on that service itself and the interfaces. But apart from that, you do need to have system integration testing suite in place to ensure that the whole system can behave as well in the different scenarios. Okay, so that's the first question. Let's see if we've got another one here. Okay, second one. You talked about barriers to DevOps adoption and that the ability to change organizational culture is a big one. So how do we overcome that issue or that barrier? Okay, so again, that's a question for me. So changing organizational culture is definitely difficult. Yeah, I don't want to make it sound like it is simple. It's not. This is kind of where the coaching comes in, and it's really working with in two different ways. It's working from the top down, so working with execs to ensure that they really get the benefits of what DevOps enablement is about. So that whole, from an exec standpoint, what they care about is being able to respond to changes in the market, and that means releasing frequently and at low risk. So if that's important to them, then they need to agree that the cultural changes need to be put in place, and that has to happen from the top down. But in addition, we also work from the bottom up. So we do identify a key project team, and we say, okay, let's make sure that that team is using Agile, the development team is using Agile, teams are delivering frequently, that automated testing is in place, and it's the right level of automated testing for your product. And then we start enabling the development teams to take on more responsibility to keep things running. So that's a big part of changing the organizational culture, is about enabling the development teams to take on more and collaborating, ensuring that collaboration is there across all the organizations, across all the teams, so that it really is shared responsibility, which I've said a few times. I think there's another question here.
So there's one on, Lorraine, if I can take this. So there's a question on somebody's using GitLab for versioning system, and what tool can we use with GitLab for auto code deployment on EC2. Again, so the typical deployment tools that we use on EC2, AWS service, talking about AWS services, are Code Deploy. Code Deploy does not have native integrations into GitLab. It does have native integrations into GitHub. But again, this doesn't mean that you can't use GitLab and deploy onto AWS. You'll have to use some other mechanisms. Like one thing that I can think of from the top of my head is there's nothing stopping you from actually running using Code Deploy to actually run a deployment on EC2 instances. And Code Deploy basically takes lifecycle hooks, and in the lifecycle hooks, as a pre-setup, pre-install step, clone your GitLab source code and build it. Do you, again, depends on what language you're using. If you're using some language like Java or something like that, which has to be compiled and built and things like that, it doesn't really matter because you're going to be deploying a WAR file or a binary from a deployment artifact. So it doesn't really matter. So there's no one answer. There are various ways of doing it. Can you do it? Yes, absolutely.
How do you convince your waterfall thinking support team that continuous deployment, in this case, the example is every 2 weeks, does not necessarily mean high risk? Okay, and that's a really good question. So how do you convince that support team? And it really is about talking to your support team about what's making them feel uncomfortable. So what kind of, what is it that they are worried about when it comes to production issues? And usually you can actually, what we've done with a number of our clients is we've gone through their issues that have happened every time they did a production deployment and discussed with them the types of production issues that they're having and determined why they're having those issues. So was it because there are code dependencies between teams, or is it because there wasn't performance testing in place? And by identifying these issues that are happening when they're doing production deployments, we can then attempt to solve those issues and introduce quality gates, so again, automated quality gates, to reduce the risk of those things happening again. And to me, that's the only way that a waterfall type support team feels more comfortable, is if they feel that all those things they're concerned about are automated, that risk gets reduced. Shiva, do you have anything to add to that?
Yeah, sure. I want to present a different picture here as an answer to that question, right? So if there is one thing that DevOps stands for, if you want to pick one thing, that is communication, right? So there has to be communication across these different teams, or if you have silos and your organization is structured that way, that's all good. But as long as communication is happening, it'll be all good. So imagine waterfall. I think waterfall is the higher risk method. In a waterfall model, what you're doing is you are bundling a lot of changes. You're taking in a whole bunch of feature requests. You're doing a whole bunch of bug fixes, and you're bundling them all together into one big change. Write documentation, write rollback procedures, get a change window and whatnot, and then you deploy that massive big change once every 3 months or a quarter, or once in a year or whatever. Whereas when you're doing agile practices, you're doing frequent releases. So what that means is that when you do frequent releases, you got to automate those releases. There is no manual intervention in those releases. So if I said Amazon is doing 50 million deployments, there is no manual person who's doing those deployments. It's completely automated. That is absolute essential. And then when you automate the whole thing, it becomes reliable. It's going to do the exact same thing every time, every release. And you're changing small things at a time because you're doing frequent releases, which means that if something goes wrong, you know exactly what has changed. In a waterfall model with that massive change, which has 10,000 features and more bug fixes, what has caused that outage or what has caused that problem, it is impossible to find out, which means that you have to roll the entire thing back. So in my opinion, frequent releases is a less risky approach than waterfall.
All right, well, thank you much, ladies and gentlemen. That does conclude today's webinar. We do thank you for your time, and thank you to Shiva and Lorraine for their presentation and information. That does conclude the session. Have a great day.